Hello everyone, welcome back. So this time we're going into a group problem. So once again, it's a group problem. I believe in you, I know you can do this. And if you need any help and you don't have anyone around you, grab a rubber duck, or maybe a stuffed animal, or a dog. Dogs are great for solving engineering problems. They're not very helpful with the math, but they are great at supporting you. I miss my dog. So with that in mind, let's figure this out. Can we solve it? Hopefully. Hopefully we can. Okay. So first off, I'm going to give you a plan, and hopefully it doesn't give you too much information this time. Last time, that was just disgraceful. I gave you way too much. So first off, check if there are any zero force members. And ask you, is member CE a zero force member? I'm not telling you. You're going to figure it out on your own. And draw free body diagrams of all of these points, D, C, and E, because that should connect to every single member, and you should be able to solve. If you don't have enough, you can always write more. And you can use your equations of equilibrium to solve for the unknowns. Okay. So with that in mind, go forth, try it. And in 3 seconds, you're going to return to me having finished it. Okay, not 3 of your seconds, but 3 of my seconds. So 3, 2, 1, and you're back. And hopefully you've got the answers. Now let's check and see if you did it right. First off, the way they're doing it is they're just jumping straight into these equations. But as long as you pick the right points, it can be fine. This is a good point to start at. Why is it a good point? Because force CD is directly in the y direction. Force DE is the only one that has an x component, which means if I solve for sum of forces in the x direction first, I don't have to do 2 equations, 2 unknowns. I can just do 1 equation, 1 unknown. Solve it right away. That's what they do. So we get the x component of force DE, which is this times the horizontal component of the slope triangle over the hypotenuse. So force DE times 3/5 minus 600 because it is resisting it. And I solve and I get that force CD is 1,000 newtons. Now since this arrow is pointing towards the point, that makes it compression. Think about it, it's compressing the point. That's probably a good way of thinking about it, which I'll have to remember for the future. Okay, now I know force DE and force CD are the only ones that have a y component. So I already know what force DE is. I just need the y component, which would be the vertical part of it over the hypotenuse, which is 1,000 times 4/5, minus force CD, because we have force CD going in tension. It is pulling, it is stretching that point. And from this we can solve fairly easily and get that force DE is 800 newtons. Now, if you had drawn this wrong, you would have originally gotten, let's say you drew force DE as in tension to begin with. You would have just gotten a negative 1,000, which would have told you that you drew it in the wrong direction. It's okay. Just remember that and make sure that if you see a negative number when you were drawing this tension, it means it was actually in compression. Now, with that, we go on to our next point. Right here at force CE. Now, this is a glorious one because these are at right angles to each other, which means there's only 2 components in the x direction, 2 components in the y direction, and guess what? There's no trig whatsoever for this. Force CE is equal to 900 newtons. It has to be. Force CD is equal to force BC, so they're both equal to 800 newtons. There's like no math here. It's glorious. So I like the method of joint because sometimes things work out beautifully, just like you see here. So some forces in the x, some forces in the y, and I'm done. I didn't have to do any work there. All I have to care about is that this is compression, it's squishing the point. This is tension, it is stretching the point. Okay, last one, you're like, whoa, oh, this doesn't look nice at all. And no, it doesn't look nice at all. This is pretty horrible to look at. Now, as a note, they chose this point right here to do just because, like, oh, well, 2 birds, 1 stone. I can go ahead and solve for AE and FBE at the same point. But it does make you have to do 2 equations, 2 unknowns. You have to do some algebra. If I had chosen point B instead, I might have been able to get away with that. But then I'd have to solve for the reaction forces. So there's issues with that approach as well. So pros and cons of both. So at point E, we have all these forces. We know that force DE is 1,000. We know that force CE is 900 newtons. We have to use our slope triangles to break everything up. But where did the slope triangle come from? It came because we were giving the dimensions, the length of everything, and through a little bit of math. This right here, we're assuming is equal. It's the midpoint. And so that'll make this 3 here 4 here, and this will be 5. It's the only way you can actually solve this. I feel like, well, how can I really trust that and make sure it's true? Well, it's because this is 6, this is 8, which is very, very similar. And if we do 64 plus 36, which is 8 squared plus 6 squared, guess what? That equals 100. Square root of 100 is 10, so this makes this 10. And so if this is halfway, that makes this distance right here 5, 5, and you can already figure out the slope triangle from that. There's always some math we can do here to figure it out. You might not see that looking into it, but it all works. So just know where the slope triangles are coming from. You're going to have to work out those similar triangles to get the problems correct. Okay, so we continue to look at this. We have 2 equations, 2 unknowns. It's not all that terrible, but you do have to solve these simultaneous equations because of how we set it up. Let me erase everything because there's a lot of stuff going on here. For this one, we took the x components first, which is the horizontal component of my slope triangle over the hypotenuse. And we took the y component second, which is the vertical component of my slope triangle over the hypotenuse, and multiplied it by the magnitude. We took into account all the directions, and then we solve. First for one, then for the other. And we get that force AE is in compression because we drew it towards the point. It's squishing the point, it's in compression. And force BE is in tension because it's pulling away from the point, pulling it is in tension. So I hope this helps you. And next time, I'll see you next time as we go over some more fun material. Have a great day.